Hello everyone, myself Kalyani Deyankar. I am a student at CEPT University currently pursuing Masters in Construction Engineering and Management. My student code is PCM24485 and I am delighted to present my portfolio for Studio 2, which focuses on construction project execution monitoring and control. This portfolio showcases study conducted on a high-rise commercial building project which is located at Cape City. It's a greenfield project which spans across 4,292 square meters. This project aids to establish a landmark commercial hub to promote sustainability and efficiency by using composite RCC steel structure design. It includes three basements, ground plus 29 floors, which majorly includes areas like shops, offices, car gardens, studio apartments, and restaurants. The scope of work for this project is divided into two major parts where core and shell works, finishing works, and MEPF works comes under the prime contractor, which is the client, and all the structural steel works are given to a separate contractor. Now moving forward with site layout and planning. Planning site layout is an essential part of any construction project because it provides the foundation for its effective completion. It includes determining the required temporary structures and facilities and where they should be placed on site. The layout which is being presented on screen is showcasing existing site layout, which includes all the site components. Now coming to risk identification and management, we identified several risks that could lead to on-site accidents, and one of the primary obstacles observed was inadequate site planning, which not only reduces productivity but also creates dangerous workplace for workers. Major risks are divided into eight categories: site layout risk, construction risk, material procurement risk, EHS risk, quality risk, design risk, financial risk, and planning risk. From all the risks identified, 20 were identified under construction risk and 10 under EHS risk. The risk matrix is used to prioritize risks based on their likelihood of occurring and severity of their impact. By using the matrix, we can identify high risk areas, develop mitigation strategies, and monitor risks for future evaluation. The risk response categories, which are avoid, mitigate, and accept, help project managers handle potential risk effectively. For a construction project, a plus delta analysis is a valuable tool for continuous improvement. Plus components focuses on those which contribute positively on project's progress, and delta components are those where improvement is needed. Some of the plus components for this project are display of safety signboards at site, closed cutouts at each floors, use of PPE kits and barricades. While some of the delta components are no safety park on site, no debris chute available, no separate toilets available for female workers. This proposed site layout consists of all the delta components which were observed on site. Moving forward with value stream mapping. Value stream mapping is not just only a tool to identify waste in a system, but it is used to analyze and assist in designing processes, tracing material flow, and documenting information flow of given product family. So to determine VSM, we consider to observe the activity of block work from 8 am to 6 pm on second floor. The floor plan showcases the location of the blockwork activity, and the wall elevation depicts how the entire wall was divided into four parts and which part was being observed. All the activities observed on the site, which comes under block work, are shown here. After evaluating current state map, we applied five green tools, which are continuous flow 5S, Gemba walk, Kaizen, and root cause analysis, which reduced total time to about 132.81 minutes. After tag time calculation, the time to be reduced for future state was coming around 143.77 minutes. The graph here showcases the difference in cycle time, changeover time, non-value added activities, non-value added but necessary activities, and value adding activities for current state and future state mapping. The total lead time observed for current state mapping was 575.48 minutes, and total lead time observed for future state mapping was 434.2 minutes. From value stream mapping activity, we concluded that 1 hour of non-value added but necessary activities delayed due to same-day block mobilization, which could have been prevented with floor-wise pre-positioning of materials. Also, the waste categories like transportation and unutilized talent observed guided the application of lean construction principles. Moving forward to work sampling, it is a popular method for evaluating on-site usage of resources and workers. It includes recording of activities being done by making random observations where we need to calculate time spent on value-added activities, non-value-added but necessary activities, and non-value-added activities. The methodology used for this study was truth-based sampling, which means observations were made at regular intervals during site tours. A team of four observers were deployed, each following a different route and different start point. Observations were conducted for 2 days from 9:30 a.m. to 5:30 p.m. with 1 hour of lunch break from 1 p.m. to 2 p.m. Four activities were observed, which are vermiculite fireproofing, plastering, block work, band beam casting, and reinforcement. In this portfolio, observations of only one student are shown for presentation purpose. For activity-based analysis, reinforcement was the most efficient with highest value-added observations, while plastering showcased least efficiency with highest non-value-added activities. Time-based analysis was performed for before lunch break hours and after lunch break hours to compare the efficiency of workers, where we observed that reinforcement was most efficient before lunch and after lunch the productivity of workers dropped. Maintaining activity had consistent efficiency before and after lunch for both days. Plastering showcased low efficiency throughout both the days. Fireproofing had moderate efficiency before and after lunch, but it was dominated by non-value added but necessary activities due to lengthy setup and procedures. Location-based analysis was conducted to compare the same activity being observed at different locations, which might affect the non-value added time. But for the activities which we were observing, the location was different but it was on the same floor, due to which the work efficiency remained mostly stable for all. In conclusion, site-level planning addressed critical compliance issues such as inadequate safety measures and welfare activities, leading to safer and more organized working environment. Value stream mapping further enhanced productivity by applying lean methods which optimized cycle time and streamlined the workflow, improved scheduling and coordination, minimized delays and maintained the quality of work. Through work sampling, we gained insights into the execution, enabling better coordination, resource allocation, and problem solving. This helped us identify inefficiencies and develop practical strategies to manage site operations effectively. Thank you for watching my portfolio presentation. I hope this overview provided a clear understanding of the work and the thought process that went into the project.